Hey guys, it's Mrs. Rooker again. Go ahead and pause the video and try the two review problems, and then I'll put the answers up. Alright, those are the answers to the review, and now we're going to move on to the final three strategies for these identity proofs. So, the next strategy that we are going to use is to get the same denominator, common denominators, and combine terms into one fraction. So remember, when we're doing these identity proofs, we're trying to get either the left side of the equation to equal the right side or vice versa. And you can see this left side is a lot more complicated than the right, so we're probably, or the best way is to simplify this left side and get it to equal that right side. To do that, we're going to get common denominators and combine. To get common denominators, I'm going to have to multiply this first equation by cosine of x on top and bottom. And this one I'm going to have to multiply by 1 minus sine of x. Sorry, this is really bad handwriting, sorry. So the first one's going to be cosine squared x over cosine times 1 minus sine x, plus the second one is going to be 1 minus sine x times 1 minus sine x over cosine x times 1 minus sine x. And we've got a lot of simplifying we need to do. And remember, we want that to equal this. Alright, so now let's do some simplifying. I'm first going to FOIL this. 1 times 1 is 1. 1 times negative sine x is negative sine x. And then 1 times negative sine x is another negative sine x. I'll combine those and I'll end up getting negative 2 sine x. And then we'll do negative sine x times negative sine x, which will give me positive sine squared x. And then I'm going to combine that with the numerator of the other one. So that's going to be cosine squared x plus that, and that's all over our common denominator, which is, oops, got the x there, cosine of x times 1 minus sine of x. So that's what I got when I combined the two fractions together. And we want to get that to equal 2 secant x. But we have a lot more simplifying that we need to do before we can get there. One thing I notice, and I'm just kind of looking for things that I can simplify. Something that I notice is that I have cosine squared x plus sine squared x. I'm going to regroup this a little bit so that those are together, because those make up the Pythagorean identity. And then we have this plus 1 minus 2 sine x is going to be over there. And then this is all over cosine of x times 1 minus sine of x. Alright, and then we'll simplify some more. Next we can replace this with 1. So we'll have 1 plus 1 minus 2 sine x over cosine x times 1 minus sine x. Alright, and then we're going to simplify some more. Take a look at that numerator. We can simplify the 1 plus 1. We can combine those. 1 plus 1 is going to be 2 minus 2 sine x over cosine x times 1 minus sine x. Now think back to some of the strategies that we talked about in the last video. We're going to have to do something with the top of that equation, or sorry, to the top of that fraction. We're going to have to simplify one of the strategies that we talked about in the previous video was factoring. You can factor something out on the top. You can factor out a GCF. If you factor out a 2, we'll be left with 1 minus sine x on top. And what we have here is cosine x times 1 minus sine x on bottom. Now we've got something huge that we can do. We can simplify this entire thing, which is awesome. And then it's always good to remember what we're trying to get this to equal. We're trying to get it to equal 2 secant x. Well, we're really close. What we have right now is 1 over cosine x, 2 over cosine x. And remember, cosine is the reciprocal of secant. So I can just rewrite this as 2 secant x equals 2 secant x. Which means we're done. Once we get the left to equal the right, we are done. And now we can move on to the next strategy. The next strategy is to use a conjugate. Multiply one side of the equation by the conjugate over the conjugate. So, what that means is, if you look here, we can multiply top and bottom of this first side. If we want to get the left to equal the right, we can multiply this first side, top and bottom, by the conjugate of secant x plus 1. The conjugate of secant x plus 1 is secant x minus 1. We'll multiply that top and bottom so we're multiplying top and bottom by secant x minus 1. We have to multiply top and bottom so that we're not changing the value of the fraction. And now what we're going to do is FOIL on the top. Secant x times secant x is secant squared x. Secant times 1 is secant, and then secant times negative 1 is negative secant. So those will cancel out. Remember, with conjugates, the middle terms always cancel out. And then we'll just have negative 1 times 1, which will give us negative 1. So that's my numerator. Then the denominator, I'm just going to distribute the tangent in there, so it's going to be secant x tangent x. And then tangent times negative 1 is negative tangent. And we want that to equal tangent x over secant x minus 1. All right, so we're going to have to do a little more simplifying to try to simplify this top part here a little bit, this. And whenever I see a squared here, that tells me that, or, you know, I kind of perk up a little bit and think that I might have a Pythagorean identity. This is going to be a Pythagorean identity. If you look back on your notes, or if you have it memorized, you'll know that secant squared x equals tangent squared x. So this top part is going to become tangent squared x. And then on the bottom, we still have secant x times tangent x minus tangent x. Again, it's always good to remember what it's supposed to equal. We want that to equal tangent of x over secant of x minus 1. All right, I feel like we're getting close. Basically, we just have too many tangents on this side, and we need to get rid of some. Remember back to the last video, you can factor out things, and on the bottom we have a GCF of tangent. Tangent is the GCF. So we have tangent squared x on top, and then on the bottom we can factor out a tangent, and we'll be left with secant x minus, when we factor out a tangent from there, it's just 1. And then we can simplify this. One of the tangents on the top cancels with the tangent on the bottom. We're left with tangent of x over secant of x minus 1, which is exactly what we wanted it to be. Alright, I'm going to zoom back out so that you can see that whole thing. So, sorry, I got that one to work, check mark. So that was using conjugates. So that's strategy number 6. And now finally, we're moving on to our 7th strategy. Look for other Pythagorean identities and make a substitution. So these right here are good to reference, also good to memorize. The more you have memorized, the easier these will be for you. All right, so we are going to try to identify those identities in this problem. So you might be able to see one of these Pythagorean identities right away. This is the same as the one right above it, so that can simplify to secant squared x. The other one kind of looks like this, but it is not at all the same. That's cosine, that's cotangent, so we can't use that. And then I'm trying to simplify this left side to equal the right side, tangent squared x plus 2. All right, so the next thing I think I'm going to do, because I don't see any more Pythagorean identities I can substitute, I'm going to get rid of that secant. I would rather have that be a cosine. So this is going to be 1 over cosine squared of x, because secant is the reciprocal of cosine. And then I'm going to multiply that by cosine squared x plus 1. Oops. And I'm just going to simplify this by multiplying this into the parentheses. So when I multiply the fraction 1 over cosine squared x times cosine squared x, that's going to be cosine squared x over cosine squared x, which is just going to cancel. So really, that first thing, 1 over cosine squared x times cosine squared x, just cancels to 1. And then I multiply 1 over cosine squared x times 1, and that's going to give me 1 over cosine squared x. And then there isn't a super obvious next step, but what I'm thinking is we've got this cosine squared x. It's kind of like the Pythagorean identity, you know, when we have a cosine squared and a 1, but I don't like this fraction, so I want to get rid of the fraction, so I'm going to convert that or change that into 1 plus secant squared x so that I no longer have a fraction. And then if you look up here, secant squared x can be replaced with this, tangent squared x plus 1. So I'm going to replace, I'm going to leave that 1 the same, but then secant squared x, oops, I'm replacing that with tangent squared x plus 1. Remember, we're trying to get that to equal the right side of the equation, which was tangent squared x plus 2. Well, we're pretty much there. Just combine the 1 on the front with the 1 on the back, and we're done. So tangent squared x plus 2 equals tangent squared x plus 2. And it worked. All right. Now we're going to move on to proving each identity by the method of your choice, which is what you're usually going to have to do, is you're going to have to choose what the best method is for any given proof. So looking at number 4, I am either trying to get the left to equal the right or vice versa. I like the idea of simplifying this right side because it looks more complicated than the left. And we've got kind of a large fraction. So my first thought, and I'm not always right the first time I try this, but my first thought is that the easiest thing to do would be to break apart that fraction first. So I'm going to break this apart to cosecant, oops, not cosine, cosecant x over cosecant x minus cotangent x over cosecant x. And if you guys want, you can, if you want to practice these, you can pause the video and try these on your own and then unpause the video so you can see my solutions. All right, and then remember, we want that to equal this. So this is the thing that we want it to equal. All right. The next thing I'm going to look for, the thing I'm really looking at is I'm trying to get from all of this junk to 1 minus cosine x. So I want to get rid of these cosecants. I want to get rid of cotangent. One really kind of nice obvious thing is we have cosecant x over cosecant x. That's just going to reduce to 1, which I think is obviously helpful because we want to have that 1. We also want to simplify this. I don't want that cotangent, so I'm going to replace that. I know that cotangent is the same as cosine x over sine x. And then I know that cosecant is the same as 1 over sine x. There's some simplifying there. And then to simplify this complex fraction, I'm going to do 1 minus, we flip the second fraction and multiply. So it's going to be cosine x over sine x times sine x over 1. The signs will cancel, and we'll be left with 1 minus cosine x, which was exactly what we wanted. So that worked. Ugly check mark, but it worked. All right. Final problem, I think. So take a look at this one and think about what method you might want to use. The easiest method on this one would be to try to take this left side and use the method where we're changing everything into sine and cosine. We're more familiar with that, it's easier to work with, so we're going to change everything into sine and cosine. So secant is the same as 1 over cosine, and then tangent is the same as sine over cosine. And then we're trying to get that to equal this. We're trying to get everything to end up equaling that in the end. Well, the next thing I notice is I can simplify because I have common denominators. I can do the next method of combining my two fractions. So this is going to be 1 minus sine x over cosine x squared. Oops, low battery. I'm going to simplify this a little bit. I'm just going to change this into 1 minus sine x squared on top and cosine squared x on bottom, because I can do more with both of those things separately than I could with them together. All right, and then again I end up looking back at my goal a lot. I'm trying to somehow get a 1 plus sine x on the bottom. And what I have now is a cosine squared x. I am going to use a variation of my Pythagorean identity to somehow get that to have a sine in it as well. Remember, my basic Pythagorean identity is sine squared x plus cosine squared x equals 1. So if I subtract sine from both sides, cosine squared x equals 1 minus sine squared x. So I'm just going to replace this bottom part with 1 minus sine squared x, because that's what cosine squared x is equal to. We'll have 1 minus sine squared x on top, or sine x, that whole thing squared on top. And then on bottom, we'll have 1 minus sine squared x. Next thing I'm going to do is, I'm just going to rewrite 1 minus sine x over 1 plus sine x. Because like I said earlier, it's always good to know what our goal is and what we're trying to get closer to. Well, I know that I have 1 minus sine x on top already. Really, I have two of them. I have 1 minus sine x times 1 minus sine x on top. I only need one of those. All right, on bottom, oops, I somehow want to get the one of these top 1 minus sine x's. I want to get one of those to cancel out. So I have to do something with this bottom. Might be hard for a lot of people to recognize, but that is a difference of perfect squares. I can factor that into the square root of 1, which is 1, plus the square root of sine x, sine squared x, which is just sine x, times 1 minus sine x. That was just a difference of perfect squares, which is awesome because now these can cancel, and we'll be left with 1 minus sine x over 1 plus sine x, which is exactly what I wanted. So it worked. All right, that is it for this video. Feel free to pause the video and catch up on those notes. Have a good one, guys.